All right, so what happened to approach zero? Now, last year, in my class, I talked about if it's on AP exam, you have to write in such a way you cannot just say, oh yeah, this e to the zero is anything to the zero power is 1 minus 1, so it's 0. You cannot just say 0 over 0. You cannot say that. The reason why AP exam want you to do this, unfortunately, not me. I didn't set this rule. AP exam says you had to say limit x approach 0 of e to the 2x minus 1 is equal to 0, and limit x approach 0 of x equal to 0. Even though that's a very simple calculation that we know 0 over 0, you had to write it out. And you had to say, okay, now you can use L'Hopital rule. So now you can say L'Hopital rule. Okay, now you can say L'Hopital rule. So, then what is L'Hopital rule? L'Hopital rule is what happened when you go to 0? You're going to get 0 over 0. So you say, well, that part I don't really understand. So what we're going to do is instead of look at the function, we're going to look at the rate of the numerator and rate of the denominator. So how do we get rate? We take a derivative. If I have limit x approach 0, d to the dx of e to the 2x minus 1. So I'm not doing quotient rule. I'm just taking derivative of numerator and denominator. And that's going to be 2e to the 2x over 1. And now if I reach x approach 0, that's going to give you 2 over 1. So that's equal to 2. So answer is 2. Very, very easy. It's not a problem. And you're going to say, well, why do we study the rate, right? I'll give you an example why we study for a rate. What happens limit x approach infinity of ln of x over x? Now this part, this question is very important for sequence and series. Very, very important. Infinity. Okay, this is a very important question. It is because for BC, in a sequence series, they want you to know like what is gonna go infinitely faster than the other one. Okay. So I'm gonna explain that again. So which one is gonna go infinity faster? ln x or x? Which one do you think go to infinity faster? X. Why do you think it's X? Okay, it's concave down, so it's have a slower increasing and decreasing rate versus that just increasing the constant rate. Yes, that would be a very good explanation for it. But in order to do that, we still look at the rate, right? So that's why we need to take a derivative of this, because even though AP is not allow you to write infinity over infinity, but I'm gonna write it this way because I don't want to spend some time to write out unnecessary thing. But in AP exam, you want to write out this way. Aiden, does that make sense? You have to write out numerator equal to 0, denominator equal to 0, or numerator equal to infinity, denominator equal to infinity. Then you can use the L'Hopital rule. You cannot use it beforehand. You cannot just say 0 over 0. Now, you know that this is going to infinity. Let's go in infinity. Then we say, hey, which ones go faster? Well, according to Brendan says, well, it's concave down. Ln of x is concave down, so it's increasing at a decreasing rate. So therefore, compared to constant rate is gonna be that. So technically, I'll just take a derivative because that's too confusing. If I take a derivative, I know this one's 1, which is constant rate. The other one is 1 over x. So it'd be limit x approach infinity of 1 over x. So therefore it's equal to 0. So the answer is 0. Not a big deal. Right? How about limit x approach infinity of x to the 99? I remember this one's on last year's AP exam. Not on last year's AP, on a practice exam. So is x to the 99 going to infinity faster than e to the x? Yes.
If you keep taking the derivative of x to the 99, it's eventually going to hit 0. whereas e to the x is always going to be e to the x.
Do you guys understand what he's saying? Because you can take L'Hopital rule multiple times. So after one iterations that we know is infinity over infinity, if we after one iteration it's gonna be 99x to the 98 over e to the x. Bottom doesn't change. Does that make sense? And if you keep on going, limit x approach infinity is be 99 times 98 times x to the 97 over e to the x. And then you say, oh, okay, well, let's plug in more. And then eventually this part will be, you know, what's the derivative of 99 times of x to the 99? Do you know? What'd you say? Yes, it's factorial. And this is very, very important for BC Calc at a sequence series. We're going to use factorial a lot. And on the bottom, still going to be e to the x. So what happens if this going to infinite? On the top has a finite number. On the bottom is going to be infinite number. So this will eventually go to 0. Does that make sense? Now, which number is going to be growing? So I was trying to figure out how do I use decimal to illustrate e to the x is outgrow x to the 99. What would be a good way?
Wait, why is it 0 again?
Because the bottom is going to go to infinite. The top is constant. It's finite.
Oh, top is constant.
Yeah, 99 factorial is a really large number by any means.
So it would be like
yeah. So I'm trying to think about how is the best way to prove that which number would it be. So let's try this. I don't know. E to the x. Oh, by 640, roughly 640. So 640 to the 99 power versus e to the 699 640. Actually, let's do this. 640 to the 99 power and e to the 640. Yep, slightly larger. But that's a huge ass number, if you ask me. No, that's a really, 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 really big number. That's right. It's so large, but this one eventually overtake that one. And I would thought it's like really large number. I would like my estimation would be probably like in a billion, but it's no, it's only 640. E to the 640 is greater than 640 to the 99. That's how crazy that is. Okay, so anyway, we just illustrated that. That's pretty interesting. I think I wasn't able to illustrate that on the other class because I gotta think a little bit more. You guys don't find it interesting? I'm interested. What'd you say? Okay, so how about this one? Again, sometimes the first L'Hopital rule doesn't always work. And this one's reach negative infinity, as opposed to before it's only reach infinity. So first of all, which case is this? This is a negative infinity square, so it's going to be infinity. And e to the positive infinity is also infinity. So if we reach negative infinity, which one's going to go faster? So we say, hey, let's take a derivative of the top will be 2x, negative e to the negative x. Limits x approach negative infinity. What am I going to get here? I'm going to get negative infinity over negative infinity, right? So we keep on going. We're going to keep on going by t to the dx, okay? So be limit x approach negative infinity of 2 over e to the negative x because of chain rule. And that's going to be 2 over infinity. 2 over infinity is equal to 0. So the answer is 0. Aiden, do you understand? Next one. Now, you're going to be like, hey, 1 to the infinity. What we just did for this one, oh no, we have one more case we had to go to. There's one more case. Limits x approach to infinity e to the negative x of square root x. Which case is this? Which kind of indeterminate form is this? Not infinity minus infinity. It's 0 times infinity. Because this, go to here, is 0 times infinity. So it's indeterminate form. But before we use L'Hopital rule, we must become a fraction. So we can change that. So you're not wrong when you say infinity over infinity. Joshua says infinity over infinity, but he's kind of a step ahead of a lot of people. Because he see it this way. Because he see it as negative x, you move down. And if I go to infinity, it's going to be infinity over infinity. So we just convert from one indeterminate form to a fraction indeterminate form. And fraction is good because I can use L'Hopital rule. So let's take L'Hopital rule here. So that's going to be 1 over 2 root x and the e to the x. Limits x approach infinity. So limit x approach infinity of 1 over 2 root x e to the x. Well, x is all on the bottom, so this is going to go to 0. This is fairly easy to decide. But even though we got a new type of indeterminate form, it doesn't mean like you cannot change it to a fraction. Matter of fact, you should change it to a fraction on all the situation in order to use it L'Hopital rule. Yes?
So infinity times infinity is just infinity.
Infinity times infinity will be infinity. Yeah, there's no other way around it. No, I mean, if very fast rate times very fast rate, it's going to be extremely fast rate. Right? So, all right. So now we're going to give you a case that where you might not have discrepancy. You're going to say, hey, Mr. Ye, why? That's a pretty dumb idea to say that's indeterminate form. It's very easy to determine 0 times infinity because anything times 0 should equal to 0. And you say you could have got 0 at the very beginning to tell me this without using the L'Hopital rule. But this is not all the case because there's a reason why they're indeterminate form. For example, limit x approach to infinity of 1 plus 1 over x. So this is a x approach infinity and to the x. Do you guys know what this is?
What did that figure to eat? Isn't it something like that?
No, but think about it, right though? Think about it. This is a 1 plus 0 to the infinity is equal to 1 to the infinity. It's indeterminate form. I'm not saying you're wrong. I'm not saying you're right. I'm just let me finish. Indeterminate is indeterminate as of right now.
I saw a math picture.
I know.
No, I still saw.
We did do this last year.
Did we?
Yeah, people didn't pay attention.
I saw like a video of Fox Fiction.
Like interest like every
Yeah.
second.
Okay, so remember, you don't remember? Okay, so I'll explain to you.
She sleeps in class.
Do you remember this equation? Okay, so last year I have said this. Last year I said if Mr. Ye to open a bank, yes, I did talk about this. I'm not crazy. If I will open a bank, I will let you deposit. Only way I'm gonna let you deposit, you're gonna deposit $1. That's it. I know you're more rich than I am, but I only allow you to deposit $1 because I gotta give you interest. And that interest is gonna be an awesome interest. It's gonna be 100% interest, right? 100% interest. So therefore, so this one is gonna be equal to $1, right? $1, and 1 plus 100% interest, 1 over n. So we're gonna say the n is how many times it compound. So this is n to the n times 1. So eventually it's going to be $1, 1 plus 1 over x to the x. Then you say, okay. Now, if you think about it, if I got this, right, this is eventually go to 0. And this is infinite amount of time, and this is infinite amount of time. The problem is, what if it didn't go to 0? What if it go into like says, if I compound every second? If I compound every second, this is what we're going to show you. I'm going to use a calculator here. And I'm going to say 1 plus 1 over x. Close parenthesis to the x. And this is the equation, sorry, to the x. And that looks like this, right? And we say, if today I compound annually, it's going to give you $2. So Mr. Ye is not going to be bankrupt because even you guys all deposit $1, I can pay you back $2, hopefully. Except I go bankrupt. Right? If I compound semi-annually, which is 2, that means I have to pay you extra 25 cents compared to annually. Now, what if it go to 4 quarterly? I had to pay you more. I had to pay you more for monthly. I had to pay you more for daily. So eventually it's going to be $2.71. What if I compound every second? I say, hey, you can choose whatever time you want to compound. So it'd be 365 times 24 times 60 times 60. Even really large number. Eventually this number plateau into E, just like what Joshua said. Or a lot of time like Jacob Rusnick will become I learned this in Family Guy. I don't know, those TikTok.
Which one?
Huh? It's a Family Guy?
Which episode? I know the math.
I think I learned something about like.
I
Oh.
watched it. They were approximating E. There's a calculation.
I think I learned something about the E.
And
They were like found by accident when they were something
Did you
like.
also get TikTok about that?
No, I mean, it was about.
I get TikTok about math.
And they were talking about.
No, I get those. I get those.
No, like the
It's like Peter Griffin teaching you
found
that.
by accident.
Peter Griffin, yeah. He always told me about Peter Griffin. I'm like, what's Peter Griffin? Okay,
My YouTube.
so we know that this is E, but in order to work out this become E, it's actually pretty interesting math. Because first of all, we can say y equal to limit as x approach infinity of 1 plus 1 over x to the x. But how do they come up with E? But as you know, that in order to use L-Hopital rule, it must be a fraction. In this case, it has an argument to the x. It doesn't have a fraction. So how do we make a fraction? We can do ln, good job. So that's ln on both sides. So it'll be ln of y. Now we keep it count right now, it's ln of y. This is the limit x approach infinity. And this one's going to be x ln of 1 plus 1 over x. Now, is this a fraction? No, it's not a fraction, right? We can make this fraction, but we got to use a little bit of advanced algebra. How do I make x to become fraction? How do you take it out? In order to make a denominator, I have to go in. I have to go in here, right? So that means ln of 1 plus 1 over x divided by something is equal to
Take out
x.
squared.
Huh?
Take out x squared.
I don't know what you mean take out x
Like
squared.
divide both sides by x squared.
Oh no, don't do that.
No.
Any ideas?
The -1.
X to -1. Can I say, hey, let's change this to down here, and if I change down here, there'll be x to the -1, right? So I can erase this, right?
Yep.
Does that make sense? So
Yeah.
so that becomes limits x approach infinity of ln 1 plus 1 over x divided by 1 over x. If I divide it by 1 over x, is that times x? Right, keep change flip. Now I can do L'Hopital rule. Now here's the thing. A lot of you guys are gonna take BC Calc 2. In case if you're taking Calc 2 again in college. L'Hopital rule of this type of L'Hopital rule will be on the Calc 2 exam. Rather than the BC exam, you're not gonna see it. So I'm talking about Calc 2 right now rather than BC. So now I take a derivative. If I take a derivative, this one is u, right? So be derivative of that is u prime over u. So I'm gonna do u on the bottom. U prime is taking derivative 1, which is 0. Taking derivative 1 over x is -1 over x squared. Is that okay? And I'll take a derivative on the bottom as well, it's -1 over x squared. What interesting to see is this cancel out. That's equal to limits x approach infinity of 1 over 1 plus 1 over x. Now when x go to infinite, this will become 1. But the answer is not 1. The answer, according to Peter Griffin, is e. Right, so there's ln y on the other side. And then you can say y equal to e to the 1. So that is y is e. It's not because Peter Griffin says so.
Peter Griffin's Moore's law. Peter Griffin and Drake. So then he made it.
Break motor. I think he told me both. What's the difference in break motor?
Huh?
Are they the same cartoon or no?
We'll see Friday.
Is that Darth Vader?
No. You like my shirt?
I do like it. It's better than my Christmas shirt.
All right, so the next thing is what happened is limits x approach 0 from the positive. Okay, which kind of indeterminate form is this one?
Zero to the 0.
0 to the 0. Good job. So can I use the same idea as last time to figure out the answer of this one? You do it. You'll be a lot easier to think of an answer. You know what happened when my son watched? So both of my son watched the match. Me and the person with no arm and no leg. And he's always whining like, "Oh, this is training so hard, and like I cannot breathe, and I'm tired, and stuff like that." And then so Max come up to me. He's like, Max literally say this to me. Max is like, "Yeah, I think I'm done with the complaining and whining business after I see that guy play." The truth, like, you have no excuse that you don't play well. You don't. The guy have nothing to work with, and he still play better than you can. Have you seen the Olympic? Like the guy play with his mouth. Same type of structure as arm. It's like his arm is a lot shorter. It's all the way to the shoulder, so he cannot tape to his shoulder. So the guy played with his mouth.
Yeah.
That guy was phenomenal too. Like, that's a lot of work.
Just play short. That's insane.
Yeah, just he had to have strong neck. Just he was Olympic. He was on the Paralympic. I saw him play. I'm like, wow. Bennett, doesn't mean you're white. You're superior.
What? Wait. When did I say that?
You're telling other people to shut up.
No, I'm from Michigan. I'm saying it.
That's actually pretty good.
I don't know how the count.
Oh, it is opposite direction. Does your flash? My dad.
So you can just, I couldn't do anything with this. It's hard to.
Do it again.
Yes, what I'm not gonna do is I'm gonna instead of putting these line
So I guess we're just.
But it's an L.
It's not divided by anything. Yeah, but it's, this is easier.
Oh, yeah.
Zero.
Oh, cosecant. One over cosecant is sine.
But you can just like take it out of that.
You can just
But
You do E to the third. That's the two left.
Oh, yeah.
You can do E.
So you can
No, you're not supposed to.
E to the.
You're not doing the other one. Yeah.
E to the zero.
That's what.
Oh, the LA both sides. And I forgot that.
Why are they two LA?
Take it again.
Oh my gosh.
Wait,
Oh.
what?
Cause that's the limit. Isn't it 1 over negative? Oh.
But you could have.
Oh.
Okay, so now I'm gonna take a derivative here. Again.
Oh.
So then you're gonna say that's 0 over 1. That's 0. So 0 over 1 is 0. 1 over 0 is undefined.
Mr. Yeah, you're rounding out one.
Yeah, and after that, you got ln(y) is equal to 0.
Yeah.
And the y is equal to 1.
I need to go up.
You do?
Oh, well, I got one in here. No, I actually just.
But I didn't try to.
We got 124. Okay. Huh? Alright, I have one last question. Infinity minus infinity, but we'll do that tomorrow.
So when are we grading this?
Safa is taking it tomorrow. We can grade tomorrow.